Yeah. So when we talk about grammar, we first talk about language. Language is nothing but a collection of sentences of finite length, all constructed from a finite alphabet of symbol. Finite alphabet of symbol is sigma. We add certain aspects to sigma, then we come up to grammar. Grammar is what? A grammar can be regarded as a device or a system or a framework that enumerates the sentences of a language. Enumerates means which can identify that this sentence is part of a language or not part of a language. Similarly, the grammar is nothing but the you can say the software aspect of a finite machine. I mean, if the finite machine was a hardware, if although it is not, it is a mathematical representation. But that mathematical representation has its own abstract understanding, which is grammar. Grammar is nothing but rules. Rules. We just write the rules. So we say a grammar of L can be regarded as a function. Now, in mathematics, rules are nothing but, I mean, rules are enforced using functions. है ना? Yes or no? Or certain other control statements like if this, then that, if this, else that, then this. Yes or no? है ना? ऐसे ही होता ना? ऐसा होता है ना?
Yes, sir.
So if suppose if now I say Tejasvi, my name is, and if I say the same thing in Hindi, मेरा नाम तेजस्वी है. And if I say my name is Tejasvi, then that is the right way to write that English. So English just doesn't mean writing words and keeping it just in the sentence. It has to have a certain specific relation within each other, with the other alphabets or the words, you can say. तो वो कौन डिसाइड करता था? ग्रामर. Now grammar is nothing but, since we are defining our languages as mathematical languages, which is computer languages, the computer languages are enforced using a function. ये बहुत ध्यान से रखना, बात को ध्यान में. Is this clear? Is this clear?
Yes, sir.
Yes, sir.
So we've got types of grammar, although this is not only related to your computer language. Grammar can be English and grammar about any language. We're just talking about language. Certain languages or certain grammars are type of prescriptive grammars, which provide some authoritative norms for a language, which means that this is the actual rules of the language in terms of just this is what it is types. Descriptive. Now, descriptive attempts to describe the usage of the language rather than rules, enforce arbitrary rules. So usage is rather more important. So if you just say English, I mean, I'm not saying you to go much deep into it, but if you see, English is not as prescriptive as Sanskrit is or as C language is. C language is very prescriptive, which means everything has its own fixed rule how to write it. If that rule is not followed, then it is it doesn't make any sense. Descriptive means English can be, there are many exceptions attached to it. Because of it, you can utilize different aspects in different sentences, and it won't make on if agar aap rules ke hisab se dekho wo ho sakta hai it might not make sense, but it still makes. But now when we talk about formal is the one which we will be talking about more often. Formal is a precisely defined grammar such as a context tree. We'll see what it is. We'll see what do you mean by defining a grammar. वो अभी हम देखेंगे, थोड़ी देर में wait करो. Next is generative. Generative means generating a formal grammar which can generate natural language expressions. Natural language and these kind of language are different. Just you need to make sure that natural language are those language which we use to speak with each other, which we use, which humans use to utilize to communicate with human beings only. But when we have to actually communicate things with the machine at a machine level, not at the high level language, because high level languages are based on English only. But if you have to communicate with the machine as a machine level, at a machine level, then then we utilize languages or grammar like formal grammars. And there are more, but currently यही समझो. ठीक है, तो we'll just stop here right now. We'll stop here. I mean, in this thing. So we'll now go back to the Chomsky classification. So now Chomsky classified grammar or languages into 4 classes. ठीक है, मैं अभी दोबारा ग्रामर पे दोबारा जाऊंगा, बट ये ज्यादा जरूरी है समझना. So there are 4. Right now what I'm going to tell is just the basic what of all the lecture is. First is recursively enumerable grammars. In fact, it is type 0. Next is type 1, type 2, and type 3. So type 0, I'll just write it here. Type 0, type 1, type 2, type 3. Okay. So ये हमने कर लिया. Recursively enumerable language, context sensitive, context free, irregular. तो नीचे से चलते हैं. Type 3 is the one currently जो हमारे finite state automata से recognize होती है, which means all the languages which we are right now, which we were talking about till now, which were getting identified or by or recognized by the DFA or the NFA, okay, or maybe it's not a language, but or maybe the type of strings which can give some output in the mule, but essentially finite state machine is more important here. Those languages are, the grammar of those languages are regular grammars. Since the grammar is regular, the language is also called as regular grammar, regular language. Okay, that's just that, grammar, language, same thing. So regular language or regular grammars are type 3. Now, how do you identify a type 3? Type 3, ये थोड़ा mistake हो गया. Type 3 are regular. ठीक है, type 3 are regular grammars. So such a grammar has restriction with the rule, which means अब पहले मैं आपको बताता हूँ restriction of rule और what is a grammar और वो क्या होता है, वो हम लोग पहले देख लेते हैं. Going back to our that slide. So a grammar, how do you define a grammar? So a grammar is defined as a 4 tuple G. Okay, so you have N, you have sigma, you have P, and you have S. Okay, just like you had the finite state machine, 5 tuples, you have 4 tuples here. Finite set of non-terminals. N means non-terminals. I'll just tell you what is non-terminal, what is terminal. Sigma is a finite set of terminals and is disjoint from N, which means sigma cannot be part of N. Now, N and sigma, in terms of, if you just look here, left and right here, I mean, normally the thing is that the capital, or you can say when we define a grammar, we use this kind of a stuff. Okay, this kind of a representation to represent your grammar. Okay, उसको हम बोलते हैं production rule. This thing is called as production rule, which means देखो, your grammar is there to define what are the acceptable strings of the language. Yes, and a set of those strings is called as a language. And if you just pick one string, we can call it a word. Okay, we can call it a word. So tell me this thing, is this a word? Is this a word?
No, sir.
No, sir.
Is this a word?
Yes, sir.
Yes.
Is this a word? Yes, but this is not a word. This might be, I don't know. But, why do you say that this is a word, this is not a word? Because you know that in English language, this is an acceptable string. String तो ये भी है. This is also collection of characters. This is also string. But you know because you know English language. That's why. So how do you know that English language says this thing? Because see, any word which does not have a vowel, fr. I'm just saying, if you just write frnd, you know what it means. But is it an actual word or the language English?
No.
No, it is not a word. But how do you make it a word? You write some level of sound here, which is like the wall sound. Okay, na? So
Sir, we can say
we can say
uh, if it is making some meaning, if it has some meaning behind it, then it is a word.
see, देखो, this is not a word in its own sense. Okay. Also, if you just, I mean, I'm talking about strict English language. Okay, ऐसा नहीं कि chatting language को आप English language बोलो. Okay, are you getting this point? Chatting language को नहीं बोलना हमने कि chat English को अपना chat करें और उसको हमने language बोल दिया. We are talking about formally defined languages. No, तभी तो उसका नाम formal languages आया ना बच्चे. जो आप बात कर रहे हो, that's an informal language. उसमें तो आप English, you can, I can include Hindi, I can include anything. But when we are talking about a formally defined grammar, we need to have this thing, production rule, which actually defines that your word, which is W, your word should be part of this thing, and then it can be reduced to some other type of word. So I'm just saying, this is a non-terminal. Capital A, capital B, capital C, and all the capitals are all considered to be terminals. So we'll just say terminals are capital letters. ये अब convention, you can change it, you can swap it. That sorry, my mistake. And non-terminals are small letters. Okay, I mean, I am saying you can do anything you want. You can keep it terminal as small letters and non-terminal as capitals. वो चीज़ है. But what does it mean by terminal? What does it mean by non-terminal? ठीक है, वो एक बार देखते हैं. What does it mean by non-terminal? What does it mean by terminal? Now, I'll just write one sentence. I hope that will be able to. Terminals, non-terminals are, just a second. एक सेकंड, यहाँ थोड़ा सा शोर है, तुम रुको तो. हाँ, बोल तो दिया है लेकिन पता नहीं. ठीक है, सो मैं क्या कह रहा था, दैट ठीक है, मिस एंड मिस्टेक, मैं वही कंफर्म कर रहा था. नॉन टर्मिनल्स इज द कन्वेंशन ऑफ कीपिंग कैपिटल्स एंड टर्मिनल्स आर केप्ट एज स्मॉल letters. I'll just keep it again. I'll just make it the correction that all the capital letters are non-terminals and all the terminals are small letters. Okay. Now non-terminals are those which are utilized as, you know, which take part in the generation of the sentence, but they are not part of the they are not the component of the sentence. Just say, for example, you know that you need to have a noun or a verb or some punctuation mark to keep your to make a sentence in English. Yes or no? You need to have these things. Now what can be a noun? Noun can be a name, noun can be a place, noun can be noun can be a thing, है ना? ऐसा ही होता है ना, यही होता है ना नाउन. इंग्लिश में ऐसा ही बोल रहा हूँ, नहीं बोल रहा. Verb is what? Verb is something like an action. क्या हो सकता है? Walk can be an action. Yes or no? Then apart from walk, run can be an action, sleep can be an action, talk can be an action, and etc. So समझ में आ रहा है? This is how you create a set of terminals or non-terminals. So if I have to give a analogous to the natural languages that we use, English or Hindi, then this noun is the terminal, is the non-terminal, and these things, name, place, thing, are non-terminal. 2 minutes. Noun is the non-terminal and name, place, thing are the terminals. Left hand side is the non-terminal, right hand side is the terminal. Left hand side में आप देखो ज़्यादातर we have only a capital A, but in the right side you have a combination of A, B, C, or you have a combination of just B, or you have a combination of small and capital letters. Right side में कोई problem नहीं है, regular language में problem. But you need to understand that non-terminals are the ones which get reduced into terminals in order to produce different sets of strings. आई बात समझ में? अब बात समझ में आई आपको? और words. ये आपको समझ में आ गया? Yes or no, guys? Do I need to repeat it again?
Yes, sir.
ठीक है, I hope this thing is clear. Now, अब मतलब क्या है इस चीज का? अच्छा, लास्ट एक और पॉइंट था लास्ट. S is the start symbol. S is considered as the start symbol. So this start symbol is always considered to be a non-terminal. एक बात और ये आपको ध्यान रखनी है, that your S will always be a non-terminal. ठीक है, this one. Okay. So in this example, just look at this example. I'm just giving an example. ठीक है, look. So you have A starting with epsilon. Epsilon means there is nothing right now. ठीक है, or A can be small a, or A can be ABC, or A can be B, or A can be ABCB. तो अब देखो सिंपल सी बात, we have to substitute the non-terminals by the terminals in order to generate different strings. So first string क्या आ सकती है? A can be what? A can be just A. A can be what? A can be ABC. A can be what? Capital B तो हो नहीं सकता क्योंकि we don't have anything for capital B. है क्या? नहीं. Or we can have ABCB. So we can have we can substitute if we had another B and B का यहाँ पे होता something like A BB, suppose. Okay, so this will help us to generate more strings. कैसे? Now A can be BB, A can also be ABC BB, then A can again be A can आगे A और क्या हो सकता है? और क्या हो सकता है? A कुछ नहीं हो सकता. Can it be more than this thing which I have written in terms of set? Yes or no? Hello. ये मैंने क्या किया? I have just written this A here. ठीक है, I have written this A here. I have written that ABC here. I have written BB there. Why? Because ठीक है, ABC ये मैंने उठा के यहाँ लिख दिया. This thing I have written first here, then this thing is here. Are you getting this point? Yes or no? Hello.
Yes, sir.
And then this B, sorry, this BB is again substituted here, and then this thing is then shown here. Okay, so these are the words or acceptable strings. ठीक है जी, किसी भी फॉर्मल लैंग्वेज कोई भी तरीका हो सकता है, वो हो सकती है कोई और भी कॉन्टेक्स्ट फ्री लैंग्वेज भी इसी तरीके से काम करेगी. दैट विल आल्सो वर्क द सेम. ठीक है, सो ये आपका क्लियर हो. ठीक है, ये टाइप 2, टाइप 1 एंड टाइप 0. अब हम आगे चलते हैं. फॉर्मल लैंग्वेज क्लियर हुआ, जस्ट फॉर्मल लैंग्वेजेस. अब हम फॉर्मल लैंग्वेजेस का टाइप हमने देखा है. देयर आर 4 टाइप्स व्हिच आर शोन बाय हायरार्की. मैं पहले वहीं पे जाऊंगा, डायग्राम में थोड़ी देर में बताऊंगा. तो टाइप 3 is the one which we have already used, and then this is type 2. So type 2 grammar generates context free languages. So context free languages are very, you know, lenient in terms of what regular language क्या कहता है. पहले टाइप 3 देखते हैं. रेगुलर लैंग्वेज क्या कहता है. रेगुलर लैंग्वेज टाइप 3 ग्रामर जनरेट्स रूल्स दैट a single non-terminal should be on the left hand side. Okay, on the left hand side there should be a single non-terminal, and on the right hand side it should have a single terminal. Okay, single terminal, or it can be a combination also, possibly followed by a single non-terminal also, doesn't matter. It can be a combination, or it can be just any terminal. Okay. Okay, so this rule, which is S is what? S is the starting symbol. Starting symbol will allow, if we are using epsilon, it means that it is also allowed here if S does not appear on the right side of any rule. ये बहुत ध्यान रखना. जैसे for example, in this example only we were looking at this thing. A is epsilon, A is also ABC, but B is BB, whereas B can also be on the right hand side. So in this idea, B cannot be allowed to have this kind of a production. So B derives A, epsilon cannot be allowed if B is coming in the right hand side. Okay, clear? I'm just talking about if B was the starting state. If B was the starting state, here we assume that A is the starting state. These languages are exactly all languages that can be decided or accepted by a finite state machine. ठीक है, so ये आपको समझना. ठीक है, one more thing, that as we have already discussed, that regular languages, regular expressions, finite automata are all equivalent. That's why formal languages, which are regular languages, they can be represented as regular expressions also. Clear? Is this clear? समझ में आ गया? समझ में आ गया? Yes or no? Hello.
Sir, please
Yes,
repeat
sir.
last sentence.
Last line ये है, we have seen that you can convert finite automata to regular expression to finite automata. So these 2-3 things are equivalent to each other. That's why
Yes, sir.
any regular language can be represented using regular expression also. Why? Because regular language finite automata से decide होती है, accept हो पाती है. या ये कह लो, all the language which is accepted by a finite state machine or finite automata is a regular language. तो finite automata regular expression को भी accept करता है ना? Yes or no? जब आप convert कर सकते हो. अरे वही बात होगी. If A is equal to B and B is equal to C, तो A is equal to C ना. तो वही चीज लगा लो, यहाँ पे लगा लो रेगुलर एक्सप्रेशन, यहाँ पे लगा लो फाइनाइट ऑटोमेटा, यहाँ लगा लो फाइनाइट ऑटोमेटा एंड रेगुलर ग्रामर. सो यहाँ पे होगा रेगुलर एक्सप्रेशन is equivalent to regular grammar, which means you can represent one in terms of the other. ठीक है, लास्ट लाइन इसका एप्लीकेशन. टू डिफाइन सर्च पैटर्न्स and the lexical structure of programming languages, we use regular languages. ये ध्यान रखना, क्योंकि आपके अभी कंपाइलर डिजाइन का जो काम आएगा वहां पे सबसे पहला स्टेप ये होता है. तो प्रोडक्शन रूल आपको पता होना चाहिए. ठीक है, सर्च पैटर्न्स जो आपके सर्च इंजन होते हैं या फाइल सर्च होता है ना आपके लैपटॉप्स में, वहां पे सर्च पैटर्न्स को डिफाइन पहले से डिफाइन करने के लिए, टू डिफाइन द सर्च पैटर्न्स बिफोर ये भी एक्चुअली देयर इज नथिंग बट देयर इज ओनली 2 थिंग्स इन अ सर्च engine. One is search query, the other is a database, and there is other aspects of ranking and etc. But how do you define search patterns is using regular languages. Clear? Yes or no? Clear हो गया?
Yes, sir.
Yes, sir.
ठीक है. Now context free Context tree is very lenient as compared to regular language. These languages are exactly all languages that can be recognized by a non-deterministic push-down automata. वो अभी थोड़ी देर में देखेंगे. But there is another automata which we will study in the next unit, which is push-down automata. So they are defined as A to gamma, where A is a non-terminal and gamma is a string of terminals and non-terminals. कुछ भी हो सकता है, doesn't matter. Still, I mean CFG में ये वाला rule is not allowed. This thing is not allowed. ठीक है, ये थोड़ा ध्यान रखना. CFG are the theoretical basis for the syntax of most programming languages. So we understand this thing. ठीक है. Next is context sensitive grammar. Type 1 grammar, they generate context sensitive. They are of the type rule of the form alpha, capital A, and then beta, and at the right hand side there is no non-terminal. Alpha, beta, and gamma are strings of terminals or non-terminals. The strings of alpha and beta may be empty, but gamma cannot be empty. तो इसको मैथमेटिकली क्या लिखते हैं कि बेटा स्क्रीनशॉट प्लीज कर लो. Alpha, comma, beta can be they can belong to null, but gamma cannot be null. This thing is very important. Okay. One thing. The languages described by these grammars are exactly all the languages which are recognized by linear bounded automata. तो अभी क्या हो रहा है? What I'm trying to explain to you is that मैं ना एक नया स्लाइड ले लेता हूँ क्योंकि व्हाइट पेज मिल रहा है. 2 minutes. ठीक है. तो अभी हो क्या रहा है? We are providing you with a type of language or grammar and उनकी machine and what is the language called. So language is same as the name of the grammar, so don't worry. ठीक है. But the machine which can accept this grammar वो हम लोगों ने अभी आपको बताया. तो type 0 में आ गया DFA और NFA. Sorry, type 0 नहीं, it is type 3. Type 2 जो भी नाम है, अब नाम अपने आप देख लेंगे ये भी. That is PDA, push down automata. Type 1 is linear bound automata and type 0 भी आएगा. Type 0 is what? Type 0 is Turing machine. ठीक है, वो भी बताता type 0 का मतलब क्या है. ठीक है. Type 0 are unrestricted grammars. मतलब उनमें कुछ भी चलेगा. They generate exactly all languages that can be recognized by a Turing machine. The languages which are called as recursively enumerable languages. Just difference यहाँ पे. इनको आप unrestricted languages नहीं बोलते. We don't call them unrestricted languages. We call them recursively enumerable languages. And the machine that they use that can be used to accept these languages or understand this thing is called as an halting Turing machine or Turing machine. They are too general to describe the syntax of programming language and natural language. Okay. They are not utilized to explain the syntax of programming language or natural language. They are in fact utilized to explain or workings of whole systems or machines. So that's what it is. Okay. So is this clear? कोई doubt?
Yes, sir.
ठीक है. Now यहाँ पे क्या था, वो लेफ्ट राइट में कुछ भी हो कोई दिक्कत नहीं है, but you should always have some non-terminal at the left hand side in terms of context sensitive grammar. ठीक है. This is just a basic identification class for you today. We are not going to much into detail in terms of context sensitive or in fact recursively enumerable. According to our syllabus, we only have to discuss about CFG. एंड देन CFG का कंपाइलर से क्या कनेक्शन है, व्हाट डू मीन बाय, वो हम देखेंगे. अगला हम जो डिस्कस करेंगे वो CFG को करेंगे. CFG इज व्हाट? context free grammar.
Context free grammar.
Okay, now one very last, one very last and very most important point is, ये इस slide से भी आप पढ़ सकते हो. Mathematically you can see that grammar क्या होता है, type 2 grammar का क्या definition है, type 0 का क्या है, type 1 का क्या है, वो मैंने आपको बता दिया है. One important aspect of is called as Chomsky hierarchy of formal languages. This thing. So they say that type 0, type 1, type 2, all the एक बात बोलते हैं. बात क्या बोलते हैं? बात ये है that a type 3 grammar is a special type 2 grammar and a type 2 grammar is a special type 1 grammar, जो कि यहाँ दिखेगा इस तरीके से. Type 3 grammar is a special type 2 grammar, type 2 grammar is a special type 1 grammar, and the type 1 grammar is a special type of type 0 grammar, which means जो if a language is a context free language, then it is necessary that it is also a regular language. Similarly, but it is not necessary that that same context free language is also context sensitive language. तो अगर एक language PDA से accept होती है, if a machine which is pushed on automata, it can accept a language, it can also accept this another language which can be accepted by a DFA. Okay, one thing. This is what is called as hierarchy. Similar for this thing. All languages which is recursively enumerable, they are also context sensitive, context free, as well as regular languages. So it is like a